Hey, angles inside a triangle. What do you know about it? Oh, they do. Yes, they all equal 180. That is a fact. And I'm going to give it a little fancy name. You can impress everybody at lunch today. Triangle angle sum theorem. All three interior angles of a triangle add to 180. That's, we've known that. Just put a fancy name to it. All three interior angles of a triangle add to a buck 80. You're going to start seeing from me this unit. I'm not going to provide the diagram because I want to see you guys start drawing your own diagram and labeling it correctly. So here, you don't need the diagram. If you like the visual, great. You don't need it though. I'm giving you all three angle measurements here of a triangle, and I'm asking a couple questions about it. So if you want to see it visually here, one of my angles is 2x. Second angle, x plus 10. Third angle, 3x minus 10. So those are my three angles right now. And I'm asking, what's the value of x? Do you know any of these angles are congruent? So don't assume that. Don't write that down. It's not there. I do have all three angles, so I'm going to ask somebody right now, hey, come up with an equation to solve for x. 8, let's roll. I got all three. Go ahead, sorry, I'll shut up.
2x plus x plus 10 plus 3x minus 10 equals 180.
Got it. There we go. Add them all up, and everybody knows they add to 180. Everyone all good there? Don't set them equal to each other. I don't know any of these angles are equal. So I'll let you guys combine like terms, move everything over, and we'll get a value of x in a second. Warming up today. Oh, didn't know we had meteorologist Spence in the house, everybody. Any more rain this afternoon, Spence? Okay. I'm asking this afternoon. What about in the afternoon?
Still don't know.
Okay, up in the air, 50-50.
Say it'll be fine. So,
Oh, now we got another one in the house. Yep. All right, what are we getting for x when you have it? 1, Anna?
30.
30, good. All right, let's do something with that now. Now find me the degree measures of all the angles. Plug it back in. Let me know what all the angles in the triangle are going to be. $12 when you're ready.
60, 40, and 80.
Got it? All right, now this is going back to yesterday's notes. What type of triangle is this based on its angles? So don't tell me scalene, isosceles, or equilateral because that's based on its sides. Look at all three angles, 60, 40, and 80. This would be a what type of triangle from our discussion yesterday? Again, don't tell me isosceles, equilateral, that's based on its sides. 60, 40, 80. This is a 9. Acute, thank you. Why? Because all angles are less than 90. Oh, good job. Any questions? Now I want to do a problem where we got some vocabulary from this year. And we got to draw our own diagram. All right, triangle ABC. Are we all good? When it tells us the name of a triangle, it's telling us the vertices, and we can label the vertices any way, any direction. Okay, it doesn't matter where you put A, B, or C. It can go anywhere. All right, angle A is 40. So why don't we plop 40 degrees in there? Angle C is 30. Let's plop a 30 degrees in there. And we're going to draw CD. So it, bisects angle C. Okay. So angle C is going to get bisected. D is somewhere on AB. Somewhere on AB is point D, and we're going to connect that to make a line segment CD. And remember, it's bisecting angle C. Before we answer these questions, let's make one thing clear here. Everyone see 3 triangles in the diagram, the 2 inside and the 1 big one. There is 180 degrees in every triangle, even if it's a triangle within a triangle. 100, ready? 180. ADC, 180. ABC, 180. Every triangle has 180, even if it's within another one. All good? All right, so now the first one I'm looking for, what is angle B? Every triangle has 180, 180 degrees in it. What's going to be angle B then? Angle B. 2 thoughts.
I'm not sure.
Okay, look at triangle ABC. We already know 2 out of the 3 angles, don't we?
Mm-hmm.
One angle's 40. One angle's 30. What do they have to total up to?
180.
Okay, so angle B? 110.
10.
There, everyone good? I already know 2 out of 3 angles in triangle ABC. Third angle has to total up to 180, so it's got to be 110. Next up, angle ACD. And remember what CD was doing in the directions. ACD, that angle should be 1, Anna?
15.
15. Why? Because it told us what in the givens?
CD is the bisector of angle C.
And we know bisectors cut an angle in half. So 30 degrees is getting cut into 2 15-degree angles. Excuse me. Great. ADC. Every triangle has 180. Come on. Every triangle has 180 degrees. ADC. 11. 5.
125.
125. Again, that's 40. That's 15. In triangle ADC, I know 2 out of the 3, so the third one has to get me to 180. So 125 and then BDC. A couple different ways you could get to BDC. When you're ready. 4, BDC, when you're ready. 55. Hey, just to make it, you could have said, I got 110, 15, subtracted them from 180 and got it 55. Or you could have said, what was the relationship between that 125 we just found and 55? These are, oh boy. Come on, these are what right here? Linear pairs, so they're supplementary. Okay? Questions? All right, let's keep trucking. This says 2 to 7, doesn't it? Yep. All righty, triangle ABC. Let me set it up. Angle C is 72 degrees. All right, we've done a few of these this year. A and B are in a ratio of 2 to 7. Angle A to B, a ratio of 2 to 7. I just don't want to put a 2 in it. That doesn't make, what am I going to do with that garbage right there? Because I know I'm going to have to set up an equation that says they're all equal to 180. So what should I be putting with the 2 and the 7? Anybody remember what the ratios? What do you got? X, yeah. Anytime numbers are in a ratio, I want to put X's with them so I can put them in an equation. Numbers in a ratio, put your X's with them. All right, now can you help me set up an equation to find X? Here you go. 12. What do you got for me?
7.
Yep.
X plus 2x plus 17 equals 180.
There you go. Everyone go to town. Let's figure out what X is. How about x before we get to the rest of the problem? 12 again, x.
12.
Look at that. It knows. I think this generator knows. It listens. It's like your phones, right? They listen to you. Angle A, angle B. I don't need to write down angle C because we already know it's 72. So plug in 12 for A and B and let me know what you end up with. 7 when you're ready.
24 and 84.
Nice job here. 24 degrees, 84 degrees. Okay, anything on the interior angles? Because now I'm going to go outside the triangle. And here's what I'm going to show you right now. You can actually take a side of a triangle, extend it, and make an exterior angle now. That's what we have to talk about. How do I find an angle on the outside? All right, first some vocabulary. Exterior angles are located outside the triangle. So let somebody just go ahead, pop out. Give me one exterior angle in my diagram right there. Triangle ABC. One exterior angle.
3.
Angle 3. All right. So one exterior angle here. Let's put angle 3 in the chart is an exterior. All right. New vocabulary. If we're talking about angle 3, what's the one adjacent that's located inside it? The adjacent interior. Spence? Angle lowercase c, right? Yep. Everyone agreed that's the adjacent angle to it. Now, what about the other two angles that are non-adjacent but still inside? I'm not a big fan of this word right here, the phrase non-adjacent. That's a mouthful for me. So I'm going to refer to them as remote interior angles. Again, those are the angles inside the triangle, not next to the exterior. So what would that be for angle 3? The two angles that are inside but not next to angle 3. Angle A and B. Everyone agrees? Remote interior. That's what we're going to call. Everyone, you know what I mean now. Remote interior. The ones not next to the exterior. All right, give me another exterior angle. 1. Thank you. Here you go. What would be its adjacent interior then? Angle lowercase a. Yep. And then if we're talking about angle 1, what would be the remote interiors for angle 1? The ones inside, not next to them. Let's hear 7 again, Kira.
Angle B and C.
Good. B and C. And then there's one more exterior, which would be angle 2. What's next to angle 2? Angle lowercase b. And then if we're talking about angle 2, the remote interiors, the ones inside, not next to angle 2, would be angle A and C. All right, why are we labeling all these? Yes, for you to become familiar with this new vocabulary term, remote interior, but also you guys have a little theorem down here we're supposed to fill in. I'm not filling it in. You guys are going to find that out as a group right now. There's some kind of pattern between these angles, and you're going to find it right now. So first thing I want you to do, you still got some white space to the right of your diagram. Can you copy these two diagrams down here for me? Copy these two diagrams. I want you guys to figure out the theorem on your own. You all right?
Yeah, I thought we were copying.
All right, you're done talking. Just copy them down. That's good. Here's what I want you to do in your group. I know you're actually going to have to talk to each other to do this. I know. You'll be fine. Find the remaining interior angles. Find the remaining interior. Then look at both triangles and see if there's a pattern between the exterior and any of the interiors. That's your job. Figure out the remaining interior angles. You can do that on your own. And then after you do that in your group, look at the exterior I gave you and see if there's a pattern with any exterior and interior angles. Go ahead. Because there should be a pattern. Anything? Should be a pattern here. Think you got something, Nate?
Yeah, the remote interior angles equal the exterior angle.
There you go. Take a look. My exterior angle here was 120. Anybody see 120 anywhere? Not the number 120, but getting 120 anywhere else? 50 and 70, which are the what? Remote interiors. Same thing here. Take a look. 150. How else could I get 150? Add up the remote interiors. Every time. Okay? Every time. So what's the theorem? How do you find an exterior angle? An exterior angle of a triangle is equal to, what do you call it when you add two numbers? The answer? Sum. An exterior angle is equal to the sum of the, what do we call them, those angles? Remote interior angles. There you go. Good job. Good job. Found your own theorem. Ready to apply it now. All right, an easy one to apply right now. Easy one. Check out this first example. Everyone see angle X, inside or outside? Inside or outside? Outside, right? So angle X is an exterior angle, so it should be automatically equal to the sum of the two remotes, which are what? Or each individual one, Spence. So 40, and the other remote interior 90, angle X is 130 degrees. All right, that's using that theorem very quickly. Exterior is always equal to the two remotes. You're gonna. I'm so happy for example 2. You're gonna be so miserable after we do it. Not that you might not be now. All right, here we go. Put this down. Might need to stretch for this one. Angle A, x squared minus 6x. Oh boy, that's not looking pretty already, huh? I love it. Angle B, 2x minus 3. ACD, everyone see that angle? ACD, where is that angle?
Exterior.
At exterior, it's on the outside. Everyone see it? A to C to D, 9x plus 27. Huh. This is going to be great. What's the value of x? All right, first thing, I need an equation. Use the theorem we just wrote down. Exterior angle is equal to the sum of the two remotes. So what would that equation look like if I use that theorem? Oh, 3. Okay. Exterior angle equals the sum of the two remotes. Good work. Can you guys clean up the left side for me? Because it looks like you have some white terms on the left side of the equal sign. Can you combine those for me? So what's it going to look like? X squared. If I combine those two like terms. Minus 4x minus 3 equals 9x plus 27. Oh, I just get happier and happier as this problem moves along. What's the deal now, huh? It's time to factor. This is going to be a factoring problem. I see x squared. I'm going to probably have to factor. I told you earlier in the year I'm not shying away from factoring in an upper level class like this. All right, problem though. You're not ready to factor right now. You can only factor unless one side is 0 equal to 0. Good. Hey, is my x squared already positive? Yeah, but let's keep it that way. Don't move it over to the right and make it negative. So move the 9x and move the 27 over to make one side equal to 0. How do I move the 9x over? Subtract it over. Let's go. I got to make one side equal to 0 before you are allowed to factor. Here we go. X squared minus 13x minus 3 equals 27. Still not equal to 0. How do I move the 27 over? Subtract it as well. Combine it with the negative 3. Ooh, some of you guys are shaking. Bad memories from Algebra 1, huh? So this will be minus 30 equals 0. All right, now it's time to factor. And look, I'm not going to make this difficult on you. This is the only method I'm going to expect of you this year to factor. You got your two parentheses. You got x and x. Now you just got to find two numbers that do what? Okay, add to negative 13, but at the same time, multiply to negative 30. I highly recommend starting with the numbers that multiply to negative 30 and seeing if you can get negative 13. So again, use your breath, your voice, act like you're alive, and talk with your group. What are those numbers that are going to be that multiply to 30 but are going to add to negative 13?
10.
Think about some numbers. Wow, discussion is wild in here. Calm it down.
There's a negative 30 that add to negative 13.
Yeah, negative 15 to add to negative 13.
Relax. How am I going to calm you down? All right, back to business here. Usually, and I did hear it within the light discussion that was going on, hey, let's throw a 10 and a 3 in there. Because you can do negative 10 and negative 3. I add those together. That does give me negative 13, doesn't it, when I add them together? Problem is, when you multiply them, what does it give you? Positive 30, and I need a negative 30. All right, so this pair won't work, unfortunately. There is another pair, though, that will give you 30, and that is 15 and 2. Negative 15, positive 2 will give you what I need. That's the only type of factoring I'm going to have you do this year. That's it. All right, now keep going. Set each of these equal to 0. Whatever's inside your parenthesis, set equal to 0 and solve. So it looks like I'm going to get two answers out of this, huh? X equals, what do we get here? X equals positive 15, and X could equal negative 2. Okay, first time this is happening this year, so we're not done with the problem, by the way. Far from done. This is the first time this has happened to us this year, so we need to slow down. Did I provide a diagram for this problem? Yes, correct? So let's take your answer of x equals negative 2. We're saying that's an answer, negative 2. And we didn't do anything wrong. It came out to be an answer, but watch what happens. Go back to the diagram for me. And plug in negative 2 at angle B. Plug in negative 2 at angle B and tell me what the problem might be. If you plug in negative 2 for x at angle B, what do you end up getting? A negative degree measure. Can that happen? Okay, so that can't happen. Even though you might plug it in for angle A and the exterior angle and get a positive angle, I get a negative angle here. It's not an answer. Okay, you cannot have a negative angle measure. So I need to go back, and because I got a negative angle measure, I'm sorry, negative 2, but that's getting rejected, that answer. Why is it getting rejected? Not because it's a negative 2, but because when I plugged it in, what did I get? A negative angle, which is a no-go around here. So everyone see that. Don't reject it automatically because it's negative. Plug it back in. If you get a negative answer, then yes, reject it. So there's only one answer here, and that's 15. Are we okay on why? Be careful now. When you get two answers, you got to go back and check to make sure you don't get a negative angle. Questions, comments? All right, we got one more, and this is totally in your group. All I'm going to do is write the answers up on the board. When your answers match, you can go on, grab a textbook, and go on to the assignment. Great problem here. It involves parallel lines from last unit and interior, exterior angles of a triangle from this unit. So once you get these answers within your group, go ahead, grab a textbook, and move on to the assignment. But if you can't get my answers, call me over. We'll figure out what went wrong.